Hello everyone. In the previous video, I have seen the very first combinational circuit, that is an adder. So in this video, I'll be discussing next combinational circuit, that is multiplexer. So let's see what is multiplexer. A multiplexer is a circuit that has multiple inputs and a single output. And the selection of one of the n inputs is done by the select lines. And it has one output selected at a time. And multiplexer is also called as data selector because the multiplexer will select only one input at a time. As you can see in the block diagram, this is the symbolical representation of multiplexer. It has 2 raised to n inputs and n select lines and only one output. So a multiplexer has 2 to the power of n data inputs, one output and n select inputs or select lines. And this is the detailed block diagram of multiplexer. As you can see here at the input side, these are all the inputs d0, d1, d2 till dn minus 1, and there will be enable input just to enable the circuit, and select lines s0, s1 till sn minus 1, and only one output. So multiplexer has different types. Already we know that it has 2 raised to n inputs and only one output and n select lines. So based on that, we can classify the multiplexer. The first multiplexer type is 2:1 multiplexer. That means it has two inputs and one output and one select lines, because 2 to the power of 1 equal to 2. And 4:1 multiplexer, it has two select lines, hence 2 to the power of 2 equal to 4 inputs. And 8:1 multiplexer, it has 3 select lines, 2 to the power of 3 equal to 8 inputs. And next 16:1 multiplexer, it has 4 select lines. So these are the different types of multiplexers. So now we'll discuss these multiplexers one by one. So first one, 2:1 multiplexer. It means it has two inputs and only one output. So this is the block diagram of 2:1 multiplexer. You can see here D0 and D1 are the two inputs, and this is the enable input just to enable the circuit, and only one select line, that is S, and one output Y. So now depending on this select line, only one input will be selected at a time. That one you can see it in the truth table here. So here S is the select line and output Y. So here only one select line, hence there are only two possible combinations. That means S, either it can be 0 or 1. So whenever the S is 0, the very first input will be selected, that is D0. Hence the output Y equal to D0. That means whatever the data available on the D0, that will be available at the output when S equal to 0. And when S equal to 1, D1 input will be selected. So that means whatever the data available on this D1, that will be available at the output when S equal to 1. So like this, depending on this select line, any one input will be selected at a time. So now we'll consider the logic expression of this 2:1 multiplexer and logic diagram of 2:1 multiplexer. So the logic expression or the output expression of 2:1 mux is y equal to d naught s bar plus d1 s. So how we have written this one is, just consider the truth table. So whenever the s is 0, the d naught input will be selected. So s is 0. So how do you represent the 0? Just by taking the complement of that variable. So s bar d naught, that is the first term. So that is d naught s bar plus one more is, when s is 1, d1 will be selected. So that is s d1, can say plus d1 s. So this is the output expression of 2:1 multiplexer. So for this expression, we have drawn this logic diagram. So the first term is d naught s bar, right? So for the first AND gate, one input is d naught, another input is s bar. So here the s line that is connected to the NOT gate, and the output of this NOT gate is, this is s bar. So the output of this first AND gate, d naught s bar, and for the second AND gate, the second term is d1s, right? So one input is d1, another input is s. So the output of this AND gate is d1s. So both the output of AND gate is connected to the OR gate, hence the output y equal to d naught s bar plus d1 s. So now how this circuit will select the one input at a time, we'll see. So for example, consider the select line is 0, s equal to 0. So if s is 0, the d naught input has to be selected. Let's see whether the d naught input will select it or not. So s is 0, here s bar, this input is 1, and another input for this AND gate is d naught. So already we know that the operation of the AND gate. In the AND gate, if any one input is 0, the output is always 0. But here the input is 1. Now the output of this AND gate is depending on the d naught input. If the d naught input is 0, the output of this AND gate becomes 0. If the d naught input is 1, the output of this AND gate becomes 1. Let's consider d naught value is 1. The output of this AND gate is 1. And the second AND gate, S is directly connected to the one input of the AND gate. So now this input is 0. Now the output of this AND gate is 0 irrespective of the D1 value, because in AND gate, if one input is 0, the output is always 0. Hence, irrespective of the D1 input, this AND gate output is always 0. So now the output y becomes 1. So that means whatever the data available on the D naught, that is available at y naught when the select line is 0. So let's consider s value is 1. So when the select line is 1, d1 input has to be selected, right? So let's see. So s is 1. Here s bar value is 0. Now the output of this AND gate is always 0 irrespective of the d naught input, right? And for the second AND gate, s is directly connected. So now input of this AND gate is 1. So now the output of this AND gate decided by d1 input. If the d1 is 0, the output of this AND gate is 0. If the d1 is 1, the output of this AND gate becomes 1, and the output y equal to 1. That means now the d naught input is selected. So this is how the inputs will be selected depending on the select line. So next, 4:1 multiplexer. 4:1 mux has 4 inputs, that is D0, D1, D2, D3 and 2 select lines S0 and S1. This is the block diagram. You can see here D0, D1, D2, D3 are the 4 different inputs and 2 select lines S1 and S0 and output Y. And this is the truth table. So S1 and S0, when both select lines are 0, 0, the D0 input will be selected, and for 0, 1, D1 will be selected, for 1, 0, D2 will be selected, and for 1, 1, D3 will be selected. And this is the logic diagram of 4:1 multiplexer, and you can see here the output expression of 4:1 multiplexer Y equal to S1 bar S0 bar D0 plus S1 bar S0 D1 plus S1 S0 bar D2 plus S1 S0 D3. The same procedure to write this output expression. You can see here when S0 and S0 both are 0, 0, D0 will be selected. So both are 0, 0. So how do you represent 0? Just by taking the complement of that variable, that is S0 bar S1 bar D0. That is the first term. You can see here S0 bar S1 bar D0. And for S10 S01 D1 will be selected, hence S1 bar S0 D1, that is the second term, plus next S1 S0 bar D2, S1 S0 bar D2, and the last term S1 S0 D3. So this is the output expression of 4:1 multiplexer. For the same output expression, we have drawn this logic diagram. D0, D1, D2, D3 are the inputs. Here S0 and S1 are the select lines, and to get the complement of these select lines we use the NOT gate. So this is S0 bar, and the output of this NOT gate is S1 bar. So now the first term is S1 bar S0 bar D0. So this here we use the 3 input AND gate. So the first input for this AND gate is D0, and second input S0 bar, third input S1 bar, and for the second AND gate D1 S1 bar and S0, and for the third AND gate D2 S1 S0 bar, and for the fourth AND gate D3 S1 S0, and the output of all these AND gates are connected to 4 input OR gate, and the output Y equal to S0 bar D0 plus S1 bar S0 D1 plus S1 S0 bar D2 plus S1 S0 D3. So this is how we can draw the logic diagram for this 4:1 multiplexer. And 8:1 multiplexer. So it's a similar procedure. It has 8 inputs, that is from D0 to D7, and 3 select lines S0, S1, S2, and depending on these 3 select lines, one input will be selected at a time. So 3 select lines means 2 to the power of 3 equal to 8. So 8 different possible combinations you can see in the truth table. So based on these select line combinations, the particular input will be selected. For 000, D0 will be selected. For 001, D1 will be selected, and so on. And the logic diagram is similar. So the first, here we required 8 AND gates of 4 input. For the first AND gate, the inputs are S, S2 bar, S1 bar, S0 bar, D0. And for the second AND gate, S2 bar, S1 bar, S0, D1. So like this, you can draw the logic diagram. See here, 8 AND gates of 4 inputs, and the output of all these AND gates are connected to the OR gate and the output Z. So here just I use the different variables. So here A, B, C are nothing but these are the select lines, that is S2, S1, S0, and I0, I1, I2, I3 are the inputs. Okay, so now we know the what is multiplexer and what are the different types of multiplexer. So now what is the uses of multiplexers? So mainly the multiplexers used in data communications for several computers to communicate over a single line, and used in radio to select one channel from many, and used to route data within a computer, and it is used for the function generator just to select the particular range of frequencies and particular waveforms. So these are the applications of these multiplexers. Let's consider this application. So I have 4 multiple sources for the sound system. I can access any one of this source for my sound system. So to select that particular source, here I am using the multiplexer. So here actually the destination is single, only one destination, that is sound system. But for that sound system, I have multiple sources. Here I have 4 different sources. One is MP3 player, docking station, and another is laptop sound card, and third one is digital satellite, and fourth one is digital cable TV. So here 4 different sources, so that I can select any one of the source at a time. I cannot select both the sources at the same time. So I have to select only one source at a time. So for that purpose, here I am using the selector. Selector is nothing but it's a multiplexer. Here 4 multiple sources are there. So that's what here I am using the 4:1 multiplexer. So the first source is connected to the D0 input of this multiplexer. Second one is connected to D1. Third one is connected to D2. Fourth one is connected to D3. And these are the select lines. A and B are the select lines. So whenever A and B both are 0, 0, the D0 input will be selected. Already we know. So for the D0, this MP3 player is connected. So that means now the sound system will access the MP3 player. And A and B are 0, 1. If B is 0, A is 1, the second input, that is D1, will be selected. So D1 is connected to the laptop sound card, so that this source will be accessed by this sound system. Same thing for 10, the digital satellite source will be selected. For 11, cable TV will be selected. So this is one application how we can use multiplexer to select the multiple sources for a single destination. So this is all about the multiplexer. In the next video, we'll discuss decoders.